Every time you turn on a tap, clean water flows out, as if by magic. But behind that simple action is an entire system of science and engineering working together. Raw water from rivers, lakes, or underground aquifers is not immediately safe to drink. It can carry dirt, bacteria, chemicals, or tiny particles that could make people sick. That's why every municipality has a water treatment process, a series of steps designed to clean and purify water before it reaches homes, schools, and businesses. The process usually begins with screening, where large debris like sticks or leaves are removed. Next comes coagulation and flocculation, where chemicals are added to the water to make tiny particles stick together, forming clumps called floc. After that, the water moves through sedimentation, where the heavy clumps sink to the bottom. To remove smaller particles, the water is pushed through filters made of sand, gravel, or charcoal. This is the step where most of the cleaning happens, as the filter traps dirt and microorganisms. Finally, the water is disinfected, often with chlorine or UV light, to kill any remaining harmful bacteria or viruses. Only after all these stages is the water considered safe to drink. Building models of this system helps us appreciate just how much work goes into something we often take for granted. Clean water doesn't simply appear. It is carefully managed through technology that mimics natural filtering processes found in wetlands and soil. In fact, engineers often design water treatment plants by studying how nature cleans water on its own. Around the world, access to clean drinking water is one of the most important global issues. Not every community has the infrastructure to build municipal systems, which is why portable filters, simple charcoal systems, and other innovations are used in many places. Understanding how filters work gives us insight into how science directly protects health and saves lives. So here's your challenge. You're going to design and build a model of a water filter that represents one of the key stages in a municipal water treatment system. You can use simple materials such as sand, gravel, cotton, or charcoal layered inside a container. Your filter should clearly show how dirty water moves through the materials, leaving cleaner water at the other end. And you'll probably get the chance to test it out with your class when you're done. To complete this project, you'll need to do the following. First, gather materials that can represent the layers of a filter, such as gravel, sand, cotton, or charcoal, and a container to build your filter in. Next, carefully layer the materials inside your container, starting with larger pieces at the bottom and finer pieces near the top. Then label each layer on a diagram or legend explaining what it represents in the municipal system. For example, sand might represent filtering small particles. Charcoal might mean removing odors or chemicals. After that, test your filter with slightly dirty water, using safe classroom materials like soil and water, and observe how the water changes as it passes through. Finally, complete a short reflection, explaining how your filter was designed to clean water like a municipal water system. By the end of this project, you'll understand that every drop of water you drink has gone through an incredible journey of cleaning and protection. Your model will help you see how natural processes and human engineering work together to provide one of the most essential resources for life: clean water.